Hi everybody, welcome back again. This is chapter 8. This is a continuation to chapter 7. In chapter 7, we talked about the IT building blocks, the data, and this is a continuation. Chapter 8 is a continuation to the fourth dimension of the IT building block, which is the data. We will be talking about enterprise databases or database concept here. Now, the topic or the topic objectives, there will be five main topics related to chapter 8. The first topic, we need to describe the main components of the database. Then the second topic, we need to address the different reasons for using a database. The third topic, which is related to the identify the different types of databases. We have also to look at in the fourth topic, we need to look at different business usage, or why businesses should use the data, the spreadsheet, when they should be or versus the database. Okay. Now, the fifth topic, which is related to the identify the different steps, which is there are 7-step process or sequence for developing database application. We will talk also about additional topics, including database normalization, as well as backup and compact, providing backup and compact databases. Let's begin with the definition of, or identify or introduce the concept of database. Database is defined as a single organized collection of structured data. These data usually stored in certain media, and they usually provide consistent and controlled pool of data. So the idea behind a database is that there are certain information that are being integrated together to formulate a meaningful or structured form of data. Now, it's very important for us. It's a good to have to manage certain kind of entities or certain kind of list that includes addresses, phone numbers, inventory, and membership. Now, the database, there are many different examples for databases that we use it on our daily life. And there are, for example, the employee database that could be a database. There could be different, the customer database. There could be the supplier database. There are many different examples that we can depict from our business environment or from our daily life. Now, the first topic here, which is the database components, and as I mentioned before, database is a collection of data and information that are needed or intended to describe certain items within the organization. Now, database, we use database, of course, in order to help us to sort different kind of data, to be able to organize data according to certain criteria, or building some kind of list of data that is based on the name, based on the postal code, based on the city, based on many different criteria or different individual item, or based on certain order of information. So in the top of that, we can establish different forms that can be used to update the data that is under or behind the form, and that we can also use the database to generate reports that will facilitate or will help us to read the information and make use of the information that are preserved in the database. Some basic components of the database that includes, for example, there is the entities and attributes. Now, the entity could be a person, could be a place, could be anything, event, condition, condition about certain data or information that is going to be. Now, the entity, each entity could have different attributes. Attributes is some kind of more information about the entity that describes the entity itself. So it's a category of data or information that explain what is the entity, and explain the different format, the data type of the entity, what kind of entity, and all the different characteristics of the entity. So each attribute is a fact about the entity. Now, here in this example here, a sample of some table here that consists of 4 columns, which is the one column says the customer ID, the second column the first name, the third column is the last name, and the fourth column is the phone. As you can see here, in this case, we can say that the entity, those represent the fields. The fields are the customer ID, the first name, the last name, and the phone number. Now, when we have data that is put for specific customer ID, so then we can refer to this as an entity. So that specific entity here will definitely, that could be the customer ID, and that entity will have attribute. For example, here in this case, we have the customer ID is defined as a number that is, for example, here it's 5 integer. So technically speaking, it's the integer data type. So the data type or the attribute of this entity or this customer ID is basically consists of maximum 5 integer, and it's of data type integer, of course, and it's numeric. It has certain format that is 5 digits long. And this is what we mean by attributes. So the attributes discuss the entity. So you can say that the entity in this case are the fields, and the attribute is the characteristics of that field. Now, when we start to have information placed, for example, for a specific customer, as in this example here, customer 11005, it has that's the customer ID. Now the customer ID has a first name and has a last name as well as a phone number. Now this information related to this customer, which is the 11005, what we call it a record. So the record is, technically speaking, one row of data and a collection of records. This represent the data in the table. That's why the next area here, we need to understand the data item, which is a specific detail of an individual entity that is stored in the database, and that is that we call it the record in a database, which is designated as a field used to distinguish one record from another. As we know here, each customer has a different unique ID or customer ID, and that's why this customer or this field here is or represent the what we call it a unique field for the record, and that's how we differentiate between different records and designate or distinguish from one record to another. Now, a relational database, there is the concept of relational database. Relational means that two tables are related to each other, or in other words, we establish a relationship between multiple table or multiple entities here. And the concept of here is that a database is in which the data are structured in a table format consisting of rows and columns, so we call it a relational database. Now, the relation is the table in database that describes an entity, so that we need to establish the relation. Now, we have something we call it tuples, which is the rows of a relation, also called the records, and fields, the columns of relation, also called attributes. So now we understand now the fields are the attributes, as well as the tuples, which is the row of the relation or certain relation in the table. Now, of course, we got also something called enterprise database, which is our large multi-user database systems developed and maintained by IT professional. We have also distinguish the enterprise database to a simple personal database that could be deployed at the personal level. Now, this diagram shows the relational database management system and how the database is stored in the disk storage, and how the relational database management system that is used to store to manage the data is stored in the system, which is to manage the storing, the retrieving, and the protecting of the data, and how to manage the user interaction with the data, as well as from the input side as well as from the output side. We move on to the second topic, which is the reasons for using database. So definitely there are important reasons for using the database. We use the database for organizing, distributing our data and information that are considered to be the primary reason for using the database, which of course it involves the process of storing the data, the process of retrieving the data, the process of building queries on the data or establishing queries, searching on the data to identify certain information that is being preserved in the database. We can also utilize the concept of editing the data, means modification of the data, adding, deleting, changing the data about certain companies or about certain people. So those are the reasons for using the database. Now, the different types of database that exist. So we can have, a spreadsheet could be a form of database. So you can say that both database and spreadsheets can be used to handle the same kind of information, but each is optimized to handle different characteristics or different type of data in a certain efficient way. Now, when the is large in terms of number of records, then the more it's very important to utilize some kind of database rather than utilizing a simple spreadsheet environments. So that's why Microsoft Access, we can utilize different kind of database engines, including the older one, which is the Fox Pro Paradox approach. We can use also MySQL from Linux environment, and as well as Oracle engine from Oracle as an Oracle database. Now, the type of database that exists, we could have a flat database, we could have text database, we could have a spreadsheet. And finally, we could have relational databases. Now, flat database, when we have all the information being displayed in a flat, in other words, it's not structured, we call it flat database. So a database that consists of a single table, when we have a single table, we refer to that as a flat database. Now, single table has been around. For example, lightweight database programs such as database components in Microsoft Works are also referred to as flat file databases or flat file manager. Now here there are more powerful programs. There are FileMaker Pro, Access, Approach, and Paradox. All these they handle multiple database or multi-table database environment, what we call it a relational database models, or sometimes they are referred to as the relational database management system. So the flat database contains a file which contains records which contains all fields. In other words, in the flat database model, we will have a single record for that is related to a specific entity, for example, a specific customer, and it will have many fields, multiple fields that describe that customer. So it is just within a single table, and it is not it's not in a structured way. So it may require entering the same information in many records, and that's what happens if we got, for example, let's say that the example that we have a customer, and this customer, there are multiple contracts for that customer. Then in this case, we need to add that customer many times for every contract. In this case, we had to re-enter the information, and this is going to be, of course, a waste time, and there could be also errors in entering the data, as well as data consistency could be violated in certain aspects. Text databases is considered to be the example of a flat database. So the flat database, you can say also text database is an example of flat database. A spreadsheet is also another example of a flat database. Now, the relational database model here, instead of having a flat database or a flat table or just a single table that represents the database, we could now break that table into multiple tables and provide some kind of link between those tables together in a structured way, in relational way, and that's why we call it a relational database model. So a relational database model contains tables which are linked together, and each table contains records which contains also fields. Microsoft Access or Oracle and other relational databases are advanced examples that provide us with the relational database capability. Now, this kind of database we use multiple tables that they are linked together, and usually when we link tables together, we use one key or shared column between those two tables. But I have provided a good example here, which is in this figure 1-2, which represent a database relationship between table for customer and contracts. So I have provided you with two tables. One of them is the customer table. The other table is called the contract table. Now, in the customer table, as you can see, it is represented by 4 fields, which is the customer ID, the first name, the last name, and the phone number. Now, the second table here, also we have the customer ID, which is we have the customer number, we have the customer ID, and we have the contract amount and the signing date. So we get 4 different fields here, and in the first table, which is also the customer table, we have 4 different fields. And as you notice, now in order for us to link those two tables, we are using a common field, that is the customer ID. So the customer ID that is considered to be a primary key or primary or unique for the first table, which is the customer table, is used in the second table, as you can see here, as a second column or as a second field, which is that doesn't have to be primary, because you know what's primary or what's unique in the second table is the contract number, because we need to have a contract number that is unique. But here in this case, if you notice here, we got, for example, the customer 11005. We have multiple contracts for that specific customers, and this is what we establish it. We establish the link between those tables using a common field, and we got the primary key used in the first table, which is the customer ID, and the primary key that is used in the second table, which is called the contract number. So those should be unique, but from the first field we used the customer ID, and the second field we used the customer ID. In this case, that provided us with a common field. Now that field, which is the customer ID that is referred to as the primary key in the first table, now it is going to be called the foreign key in the second table, and this is how we establish the link or the relational database model. And for this example, there will be 3 contracts for the first customer, which is in this case 11005 by the name Owen. So Owen, we have 3 contracts as can be elicited from this example. So again, each customer can have several different contracts in a flat database model. Now, if we have this in the flat database model, then we had to repeat the information many times in a flat model. So, and this will cause us to create a database that is not being normalized, and in other words, they are repeated fields, repeated rows or repeated information, repeated columns, and this is not going to. It's going to be a lot of typing. Now, the next topic here is developing database application. There are different steps or different 7-step process or sequence in creating a customized database routine. We need the first one is to study the problem. So we need to look at the problem. We need to describe the system, the data entry, the input requirements, the inquiry requirements, and the output requirements. We need to go to the next step, which is determine the requirements. In other words, determine the problem, the characteristics of the problem, how the database is going to be created, the processing how the processing is going to happen. We need to design the database. So once we study, then we identify the requirements, then we need to design the database. Then finally establish a search technique or searching or indexing capability, and create that database and provide the index, and then design the application that will work with that database in terms of the data entry screens, the report generation model, and the query processing methods. The last topic here we need to address it, which is called database normalization. Database normalization is the process of structuring data to minimize duplication and inconsistencies, and this is the concept of moving or transforming the flat database table model into a normalized database, a normalized structured database, and by establishing structuring of the data, by establishing relational database model that will provide us with no duplication and provide more consistencies here. So the process usually involves breaking down single table into two or more tables and defining a relationship between those. Also, to take into consideration that there are two important techniques that is used for database. One of them is called compacting, which is rearranging the data and object to decrease the size or the file size, as can be elicited from this diagram, as well as backing up. So we need to make sure also the data is being backed up, and the process of making sure that the copy of the database file there's a copy in order to protect against loss or damage of the data. Now, of course, for backup, there is also a restoration process that must be addressed at the same time. Thank you.